Good morning, sir.
Good morning, Dharnidharan. Welcome you to this video lecture series on electrical wiring and safety. This is Assistant Professor Jagdish from Department of Biomedical Engineering, and I welcome my student Dharnidharan from third year BME to have a small discussion and DT session video on electrical load types and calculation. Welcome you, Dharni.
Thank you for letting me in, sir. We'll have this conversation.
Okay, let's move on to the first slide of this particular video. So this is about electrical load. So here I have described what is meant by electrical load and what are all the different types of electrical load available in our residence. Actually, this is not for the industry. This is for a simple residence here. This is in simple terms, electrical load means any device or system that consume electric power. So I have listed out few images over there for our understanding. Even it is a simple fluorescent lamp, even it is a simple light, our day-to-day applications like air conditioning systems, washer, dishwasher, vacuum cleaners, hair dryers, and whatever thing whichever consumes electricity or electric power is considered as an electric load. So let me move on to the next slide. So why it is important for us to understand this electrical load? You just brief with the
Yes,
help
sir.
of the slide.
I would like to explain about it, sir. Sir, usually loads can be classified in diverse ways, including resistive, inductive, and capacitive types. So the different based on their how they use the energy, how they consume the energy, how precisely it impacts on the electric circuit. This is all about how the load is being distributed equally. So each load type has its own method of power handling, so which is basically why load calculates in vital for electrical setups.
So thank you for explaining. So I would like to add few more points on what is resistive load. So
Yes, sir.
resistive load is the load which directly convert the power what it is available into another kind of energy. For example, in terms of light or heat. For example, take a simple fluorescent lamp or a simple bulb which convert the electrical energy what it consumes into the different kind of energy, that is light. And if you take any kind of water heaters, any kind of induction stove, it consumes energy and convert that into heat. So we are converting one form into another form, which is called as resistive type of load. And when you talk about capacitive type of load, as the name indicate, it consists of capacitors, where energy is being stored for a certain duration of time, and it has been delivered whenever it is required. So it is a temporary storage kind of device. So if the load is like that, we call that as a capacitive type of load. And when you go for inductive type, so the inductive type of load includes magnetic induction. So it works on the principle of Fleming left hand rules. For example, when you take applications like motors, induction motors, normal centrifuge motors. So these motors run with the applications of magnetic field as well as the electric field. So when such kind of activities involved, magnetic activities involved, we call that type of load as inductive load. So this is the brief classification of basic three loads. One is resistive, inductive, and capacitive. Let's move on to the next slide.
Next slide. Yes, sir. So, sir, here I would like to explain the different types. As I said in the before slide, I would like to just expand it. So, resistive load, which is nothing but we can compare that with electrical heaters, then irons, glaciers. Example, current and voltage on the same phase. So, when it comes to inductive load, it comes to electric motors, fans, pumps, transformers. It features like power factors. So when it comes to capacitive load, it is like capacitive banks, UPS capacitors, which are basically which stores the electricity, and features like power factor is below one leading. So balance inductive effects, sir. So these are all the basic three different types and devices which comes under these three types, sir.
Okay, let's move on to the next slide. This is just an example of certain applications listed over here for your understanding.
Yes, sir.
And this is about importance of understanding electrical load. So why the electrical load calculation is very important whenever we are using it it is the first and most important point is to prevent overload and to improve efficiency and to enable certain backup plans and enable solar planning and to reduce the utility bill. So could you please brief on all these points, Dharnidharan?
Yes, sir. So prevents overloading is like avoiding tripping or breakers or damaging circuits inside the circuit, and improving efficiency is nothing but better appliances used and minimize the waste. So minimizing the waste is one of the efficient thing that we have to do in today's world. And enabling solar and backup planning is to like sizing your solar panels or generator system depends on the load, how much we are going to consume. And the last point is reducing utility bills. So these things will absolutely help us to manage the consumption and the other loads. So sir, basically in this whole session we come to know about how a load is being distributed and what are all its types and how it works and how we can reduce the consumption or how we can manage the consumption. So the session was very helpful for me to understand how the load works, sir. Thank you, sir.
So thank you, Dharnidharan, for joining this video. So in our previous video, I have briefly described about in the same lecture series, I have discussed about how to calculate electrical load of simple residential building with diagrams and example problems. If you want to have a note on that calculation part, you can go back and see that video for your better understanding in terms of practical approach. Thank you for joining. Thank you all for listening. Thank
Thank you,
you.
sir.